Hello, everyone. This is Professor Jeff Wilkerson at Luther College talking to you once again about what you might want to look for in the night sky. And I thought this week, after several weeks in a row of talking about geometry, we might leave the geometry alone for a week or two here and talk about Orion. This is one of the more popular constellations in the sky, and right now is a great time to observe it. I was watching it crawl over the horizon, one of the very few clear nights we've had in a while. It's not been clear for us much lately. We've been buried in the fog here in northeast Iowa. And I was watching Orion climb over the eastern horizon about 6 o'clock one evening. And so this is a pretty good time to get out there and look at it. One of the themes that we've addressed in this series, and I encourage you to go back and look at all of them again. I mean, why wouldn't you? So go back and watch those videos. But one of the things that we've addressed is sort of how we associate certain objects, certain constellations, certain stars with certain times of the year. And Orion's definitely wintertime. As here in January, we're watching this constellation climb over the horizon, and we're doing this we're suggesting this for the week of January 11th. That this is when you might want to go out and observe Orion. But what we're about to say is, I was observing Orion. I was getting up in the early morning hours, well before sunrise in the fall, and going outside and seeing Orion rise then in the morning, and way back in probably September, and then going to in the spring, as we move through the spring and get into April. You'll still be able to see Orion as it gets dark further across in the western sky, headed toward sunset. You'll be able to see Orion setting just after the sun. So you had ample opportunity to watch Orion. Orion's a fairly recognizable constellation. That's why it's one of the more popular. You've got the 3 stars in the belt right here, and then 2 really bright stars. The stars of winter are great. I mentioned this before too, is that we have this time of year where the sky tends to be really dark because the moisture freezes out, and so you can see the stars really brightly this time of year. And then we just happen to have some of the brightest stars in the sky right here. Most of the lists that you'll look at would suggest that Rigel is the 7th brightest star in the sky, and Betelgeuse is the 10th brightest star in the sky. There might be slight variations depending on how people measure that, and the Betelgeuse made the news last year as it got suddenly dimmer, and so it got significantly dimmer. It has since re-brightened a fair amount, and so the brightnesses of these stars do change. And one of the interesting things to go out and look at these 2 stars, they're both supergiant stars. So let's talk about that first of all. They're both supergiant stars, which means that they are high mass stars that have burned all of the hydrogen in their core. So most stars that you look at in the night sky are what we would call main sequence stars that are quietly fusing hydrogen into helium way down in the core of the star. The sun is one of these stars. And so when the sun fuses all of its hydrogen into helium, it's going to ascend the asymptotic the giant branch, excuse me, and then it will have a helium explosion and drive helium core fusion, and then ascend the asymptotic giant branch when it's fusing hydrogen into helium and helium into carbon in shells around there alternately. And so that's low mass stars have this sort of evolutionary path where they get redder, cooler, redder, and much more luminous as they get bigger. High mass stars do the same thing, but high mass stars have a different type of path that they flow in. This is a little more condensed, and high mass stars do everything faster than low mass stars. So Betelgeuse and Rigel are very, very high mass stars. They're both somewhere in the neighborhood of 20 times the mass of the sun, and they've fused all the hydrogen into helium in the core. They'll do that very quickly. High mass stars get rid of that hydrogen quickly. They've evolved off, and now they have core fusion and or shell fusion of various types going on. And we rank these as these supergiant stars that have left the main sequence, no longer fusing hydrogen into helium in their core. They're both, interestingly enough, not only about 20 times the mass of the sun, they're both somewhere in the neighborhood of 8 million years old. Remember, the sun is 4.5 billion years old, a little over 4.5 billion years old. So these are very young stars, but very far evolved, because high mass stars, again, evolve very quickly. And when you leave the main sequence, you get cooler. And so Betelgeuse is, if you've heard the phrase red giant, Betelgeuse is you would call a red giant. It's a red supergiant, but it is a very red star. It has a surface temperature of about 3,000, a little over 3,000 Kelvin. A Rigel is a blue supergiant, which you don't hear so much about. And so you have Rigel out there as a blue supergiant with a surface temperature of 12,000 Kelvin. Compare that to the sun of about 5,800 Kelvin. And so it's hotter than the sun by quite a bit. But when it was on the main sequence, Rigel would have been somewhere in the neighborhood of 30,000 Kelvin for a surface temperature. So it has cooled dramatically. But that makes Rigel look blue and Betelgeuse look very red. If you ever doubted the colors of the stars, I think you can look at these two and see these two together and see that they're very much a color difference. But if you want to enhance that, get a couple of paper towel tubes and with your left eye, point the paper towel tube at Betelgeuse, so you're looking at Betelgeuse with your left eye only, and look at Rigel with your right eye only, and that'll confuse your brain. This will get you going for a while to see two dots of light that are very different color each with your different eyes like that. So it's worth giving that a try to really see the color difference between these two stars as you pop out there and you look at them. Betelgeuse is so large, so these stars are huge. They expand and cool once they leave the main sequence. Betelgeuse is so large that if it were in the solar system, its surface would be well out past the surface of Mars and maybe significantly further than that. When I was growing up, one of the truths that we had was that you couldn't see the surfaces of stars. Stars were not resolvable, we would say. They looked like pinpoints of light. We did not have the ability. They made an angle that was so small. Uh-oh, we're doing geometry again. I can't help it. They made an angle that was so small that even with the best telescopes, that angle right there, we couldn't see the separate sides of the star. We couldn't actually measure the size of the star. They just looked like pinpoints of light. But that's changed in my lifetime. And we are able to resolve the surfaces of some stars, not very many, but Betelgeuse is one of them. Betelgeuse is a very large star that we can see the surface of. And so we're actually able to see that as an object, not as a point of light. So these stars, blue supergiant, red supergiant, evolved stars, so both will presumably become supernova, big explosions sometime in the next while, million years, 100,000 years, 500,000 years. They're headed that direction. And there'll be slightly different types of supernovae probably, since this is a blue supergiant and this is a red supergiant, but we don't know everything about the evolutionary phases of these stars. It is possible for these supergiant stars to be red supergiants and stay there, be blue supergiants and stay there, or they may loop between red supergiants and blue supergiants. So these temperatures may actually change over time. So it's possible that these stars could be in one of these processes where their surface temperatures would get, in Betelgeuse's case, much hotter over time. So all of this is great. All of these are great supergiant stars for us to see and to look at, really bright stars in the night sky. So when you go out to see this evening or sometime in the next couple of weeks and look to the east, not too long after dark, 6 o'clock at night, you should be able to see Orion climbing into the sky. Think about all of these stellar evolution things and really appreciate the color difference between Rigel and Betelgeuse as two different, a blue supergiant and a red supergiant star. And take a look at that and watch this Orion get higher in the sky over the coming months. So keep an eye on this for the next month or 2 or 3 and see as it gets dark, Orion be further and further across the sky. Great time to go out and do that. I hope you have clear skies this week and keep watching the skies, and we'll have more for you next week. Thanks, everybody.